Hello, students, and welcome to our lesson on understanding and solving absolute value inequalities. So, today we're going to do something a little different. We're going to complete an ed puzzle. And if you're watching this video, you're probably already there. And the ed puzzle will allow us to check for understanding along the way and make sure you guys get the practice you need. So, I want you to believe you can do this. These are a little bit tricky. Um, you're going to get your lesson done. We have some exit questions. And for homework, I want you to do number 2 to 14, the even problems in your paper. Remember, you're successful when you have the confidence in your ability to learn. And for today, you're successful when you've completed your ed puzzle lesson. Your name is on your homework, and you've figured out when you're going to sit down and do that. So let's get centered and block out distractions. Have your lesson page, binder, and pencil ready. Open your computer. We're going to go to quarter one, November, and then November 4th. And just as a reminder, your homework should be submitted in Schoology. You should do that, I would say Friday after school would be a good time to do it. No later than Saturday, please. We can get that on the first quarter marking period. So, as we begin, let's be reminded that slow and steady wins the algebra race. So, today we're talking about inequalities that are of the type with absolute value. So, we're going to have inequalities that have greater than or equal to, such as this. The absolute value of x is greater than or equal to 5. And we're going to have absolute value inequalities of the type that are less than or equal to, such as this type here, the absolute value of x is less than or equal to 8. So to solve these, let me go through this. Remember, we're going to make two cases. So we're going to have, first we isolate absolute values. Then we make our two cases. X is greater than or equal to 5. And then in our second case, x is less than or equal to negative 5. Now these are already solved. We've already got our x value isolated. So we're talking interval notation and graphing. So when we graph, if x is greater than or equal to 5, we'll have a solid filled in dot on 5 with our inequality, our line, our graph will extend to infinity. And that's this first one. For x is less than or equal to negative 5, we'll have an closed dot on negative 5, and our graph will extend toward negative infinity. So that's our x is less than or equal to negative 5. Now for interval notation, we have an open parenthesis for negative infinity. So we have negative infinity to negative 5, which is a bracket. And then we write our or, it's really compound, and then we have our bracket again. This should be negative 5. Then we have our positive 5, comma, positive infinity, parenthesis. And that's how we do the interval notation for this greater than or equal to inequality. So now when we do less than or equal to, we're going to have the absolute value is already isolated. So x is less than or equal to 8, and x is greater than or equal to negative 8. Now, where do you see what happens with the graph here? So these are solved. So if we have x is less than or equal to 8, we've got a solid dot on 8, and our graph extends to the left. For x is greater than or equal to negative 8, we have a solid dot on negative 8, and our graph extends to the right. However, the solution to this problem is only the overlapping region between negative 8 and positive 8. So for that reason, the way we graph these, we have the closed dot on negative 8, we have the closed dot on positive 8, and then we connect those, and that is how we graph the less than or equal to inequalities. So what I want to do is I'm going to rewrite this up here so I have room for my interval notation. And I'll clean up down there. And then my interval notation, in this case, is going to be a little simpler. I've got brackets on either side, and then I have negative 8, comma, 8, and that's our entire answer. So what does this mean? This means that absolute value inequalities are really compound inequalities. So the way we can think of this that might help us remember is that the less than or equal to are our and, got my y there, inequalities, and are greater than or equal to, those are the or inequalities. Now we've got 4 steps when we solve these. Okay, so when we solve these, the first thing we want to do is isolate the absolute value expression. The second thing we want to do is to create 2 cases. The third thing we want to do is solve both inequalities. And the fourth thing is to graph the solution and write the answer in interval notation. So I want you to make sure and remember these steps. You know, I'm not one for these little tricks, but if this mnemonic helps you, that's okay. But I want you to know what you're doing. You're creating 2 cases. The first case, let's look over here. In the first case, you keep the original inequality. In the second case, you flip the symbol of the inequality, and then you switch the sign of the non-absolute value term. And that is what we've done here and here, okay? Because the non-absolute value term here was a positive 5. Here it was a positive 8, so we gave it the negative. So let's try a few of these and let's see how you do. So on each page, I have at the top, I want you to pay attention, the 4 steps. Isolate the absolute value term. Create the 2 cases. When we create the 2 cases, case 1, we will keep the original inequality, and in case 2, we will flip the inequality symbol, and then we will switch the sign of the non-absolute value term to the opposite of whatever it is. So that's step 1, step 2. For step 3, we will solve both inequalities, and then we will graph them. I can call that 4A, and then we will write them in interval notation. I can call that 4B. So let's take a look at this first inequality. The absolute value of x is less than 7. So we've isolated absolute value. That's step 1 is done. So now we'll create 2 cases. So we have x is less than 7. We've kept the first case. And then we write x is greater than negative 7. So for the second case, We flipped the inequality symbol and switched the sign of the non-absolute value term. So these are already solved. And the way we can write this is -7 is less than x. Think about this. And x is less than 7. So let's graph. So we have open dot on -7, on +7, and this is a less than inequality. It's of the and type. So we just simply connect those. We will have parentheses to represent the open dot, and our interval notation is -7, 7, and we are finished, and this is our final answer. So for number 2, I'd like you to try that on your own and then come back to the video. Okay, I hope you tried it on your own. We will rewrite these. X is greater than or equal to 4. And then case 2, x is less than or equal to -4. So these are already solved. So let's sometimes it's easier to graph next. So if x is greater than 4, I have a solid dot on 4, and my graph extends to infinity. If x is less than or equal to -4, I have a solid dot on -4, and my graph extends to infinity. In my interval notation, open parentheses, -infinity, comma, -4, bracket, then the word or, bracket for that solid dot, 4, comma, infinity, parentheses always go around infinity. We can write our final answer as x is less than or equal to -4, or x is greater than or equal to 4. Okay, let's move on to number 3. And I'd like you to try it on your own using the 4 steps, 1, 2, 3, and 4. Your clue is right here. Case 1, keep the original inequality. Case 2, flip the inequality symbol, switch the sign of the non-absolute value term. Okay, so let's solve number 3. We rewrite our two cases. X minus 1 is greater than 6, and x minus 1 is less than -6. And we'll add 1 to both sides, which gives us x is greater than 7. And we will add 1 to both sides of this inequality on the right, which gives us x is less than -5. So let's go ahead and graph this. So we have x is less than -5, open dot. X is greater than 7, open dot. In our interval notation, we have -infinity, comma, oops, I think let me make that a little more correctly. It's negative, no, that was right, -5. Okay, -5, parenthesis, the word or, parenthesis again, 7, comma, infinity, parenthesis. So we'll write our answer. X is less than -5, or x is greater than 7. Okay, try number 4 on your own. Okay, so absolute value here is isolated. X plus 2 is less than or equal to 7. X plus 2, flip the inequality symbol, make the 7 negative. We'll subtract 2 from each side to have x is less than or equal to 5. We'll subtract 2 from either side here to have x is greater than or equal to negative 9. So we start with a smaller number. Negative 9 is less than or equal to x. Think about this on the number line, and x is less than or equal to 5. So this will be a connected graph. Remember, it started out with less than or equal to. So we have a solid dot on negative 9 and a solid circle on 5. We simply connect them, and our interval notation is easy. In this case, it's negative 9, comma 5, and we're finished with number 4. So let's move on to 5 and 6. And remember, the steps are the same. The inequalities might get a little more difficult, but the steps are the same. So we're going to isolate absolute value, create 2 cases, solve each of those inequalities separately, and then we'll graph and write our answer in interval notation. So absolute value is already isolated on number 5, so we can make our 2 cases. 2x plus 5 is greater than or equal to 3. That's case 1. We keep the original inequality. Now for case 2, we will flip the inequality symbol and switch the sign of the non-absolute value term, which is the 3. So we will write 2x plus 5 is less than or equal to negative 3, and we'll solve these now. So first we subtract 5 from each side. 2x is greater than or equal to 3 minus 5 is negative 2. I hope you try this on your own first. And then we will divide by 2, and x is greater than or equal to negative 1. We'll subtract 5 from each side in this inequality. 2x is less than or equal to negative 8. We'll divide by 2, and x is less than or equal to negative 4. So x is less than or equal to negative 4, or x is greater than or equal to negative 1. We'll use closed dots on the graph. We have negative 1, and we know that x is greater than or equal to negative 1. I'm sorry, x is less than or equal to negative 4, greater than or equal to negative 1. So here's our negative 1, greater than or equal to, here's our negative 4, less than or equal to, and our interval notation starts with negative infinity, comma, negative 4, bracket, because we have a closed circle, or again, bracket for the closed circle, and we have negative 1, comma, and then positive infinity, parenthesis. So here's our final answer. Okay, number 6, please try this on your own before you follow along with me. Okay, in number 6, absolute value is not isolated. So we have to isolate that absolute value term first. So we'll add 1 to each side of this inequality. Whatever we do to one side of an inequality, we must do to the other. So we have the absolute value of x plus 3 is less than 6. Now we can make our two cases. X plus 3 is less than 6. X plus 3 is greater than negative 6. So we'll subtract 3 from each side of the first inequality, and we have x is less than 3. And we'll subtract 3 from each side of the second inequality, and we have x is greater than negative 9. So we've got, let's think about this. We have an open circle on negative 9 and on 3, and x is greater than negative 9 and less than 3. So this is a connected graph. And we'll write our answer, negative 9 is less than x, and x is less than 3. Okay, let's move on. Doing good. Remember, 4 steps. Isolate absolute value, create two cases, solve both inequalities, then you're going to graph, excuse me, students, and write your answer in interval notation. So we're on number 7. And we have 3 multiplied by the absolute value of 2x plus 8 is less than or equal to 30. So absolute value is not isolated. So what we need to do is divide both sides of this inequality by 3, which will give us the absolute value of 2x plus 8 is greater than or equal to 10. Now that absolute value is isolated, I can go ahead and make two cases. 2x plus 8 is greater than or equal to 10. 2x plus 8 is less than or equal to negative 10. So starting on the left, the first thing I'll do is subtract 8 from each side, which gives me 2x is greater than or equal to 2. And then I'll divide both sides by 2, which gives me x is greater than or equal to 1. And on the right side inequality, I will again subtract 8 from each side so I can isolate 2x. And I'll have 2x is less than or equal to negative 12. And when I divide both sides by 2 so that I isolate x, I will have x is less than or equal to negative negative. This should be an 18. Oops. Sorry, folks. Got my mind on something else today. Okay, now divide by 2. X is less than or equal to negative 9. So I've got x is less than or equal to negative 9, or x is greater than or equal to 1. So let's graph that on the number line. So x is greater than 1, greater than or equal to 1. It's a solid circle. And x is less than or equal to negative 9. Again, a solid circle. And we write in interval notation parentheses, negative infinity, comma, negative 9, or we had the less than or equal to and greater than or equal to, so we need the brackets. And we have 1, comma, infinity. And parentheses always around infinity and negative infinity. Okay, so let's work on number 8. but I'd like you to try it first before you watch me do it. So for number 8, the first thing we need to do is clear this fraction. We need to multiply, get a nice bright color. We need to multiply both sides by -2. Okay, and that's going to give us 4x minus 8. Now, we multiplied by a negative number. That means we need to flip the inequality. Let's not forget that. So 4x minus 8 now is greater than or equal to 12. -6 times -2 is a positive 12. Now we can make two cases. In our first case, we will have the original. This is our new original inequality now that we've isolated absolute value. So we will have 4x minus 8 is greater than or equal to 12, and then 4x minus 8 is less than or equal to -12, and we will solve those. So we'll add 8 to both sides. And 12 plus 8 is 20. And we will divide both sides by 4. And x is greater than or equal to 5. On the right side inequality, we will again add 8 to both sides. Now we have 4x is less than or equal to -4. And now we'll divide both sides by 4. And we have x is less than or equal to -1. So we will write this x is less than or equal to -1, or x is greater than or equal to 5, because we will have a gap in our graph. So we need a solid dot on -1 and a solid dot on 5. And our interval notation will be -∞, comma, -1 bracket, or again bracket 1 comma infinity, and parentheses always around infinity. So how did you do? Let's move on. Okay, same rules. The rules haven't changed. We isolate absolute value. We create two cases. We solve each inequality, graph and right in interval notation. So absolute value is not isolated here in number 9. So try number 9 on your own and then come back to the video. Okay, so first what you want to do here is add 3 to both sides, which would give us 10 multiplied the absolute value of x minus 4 is greater than 50. And the next thing you want to do is divide both sides by 10, which will give you the absolute value of x minus 4 is greater than or equal is greater than 5. So now we can make two cases. So we have x minus 4 is greater than 5. Case 1, we keep the inequality. Case 2, x minus 4, we flip the inequality symbol, and the 5 will be negative. So let's go ahead and solve those. We will add 4 to both sides, and we have x is greater than 9. And we'll add 4 to both sides on the right side equation, or inequality, excuse me. which gives us x is less than -1. So we have x is less than -1 or x is greater than 9. And we need to graph that. So open circle on -1, open circle on 9, which our graph isn't quite big enough. There's my 9. And our interval notation, -infinity, comma, -1, parenthesis, because we have an open circle, or again, parenthesis for that open circle, 9, comma, infinity, parenthesis. And we are finished. So our last problem for the day, number 10, looks complicated. Slow and steady wins the race. Try it on your own and then come back to the video. Okay, first thing we want to do is subtract 11 from each side. We need to isolate absolute value here. That gives us 1/2 times the absolute value of 4x minus 4 is less than or equal to 15 minus 11 is 4. Now we need to isolate absolute value. Dividing by 1/2 is the same as multiplying by 2. So that gives us the absolute value of 4x minus 4 is less than or equal to 8. Now we have absolute value isolated, and we can make two cases. So we have 4x minus 4 is less than or equal to 8, and 4x minus 4 is greater than or equal to -8. Let's go ahead and solve the first problem by adding 4 to each side, which gives us 4x is less than or equal to 12. And then we will divide by 4. And x is less than or equal to 3. On the right side inequality, again, we will add 4 to each side. So we have 4x is greater than or equal to -8 plus 4 is -4. And then we will divide both sides by 4. And our result is x is greater than or equal to -1. So we have -1 is, now think about this, if x is greater than -1, that means -1 is less than or equal to x. And of course, x is less than or equal to 3. So we need a solid dot on -1 and on 3. And we simply connect them, and we enclose those solutions in brackets. And that's it for the practice, but let's go on to our exit ticket. And it's really important, folks, that you memorize this. It will make your life easier. So what must be isolated? Absolute value. We want to write this on notebook paper. That would be great practice. What should we do next? We make two cases. How do we handle case 1? We keep it as is. How do we handle case 2? We flip the inequality symbol. And we change the non-inequality sign to its opposite. And then what's next is we solve both inequalities. And we have our solution. We should graph it, and we should write it in interval notation. Okay, so before you leave, please remember our exit ticket is done, but just remember you have homework to submit in Schoology and clear your area, collect your things. You don't want to forget anything, and return any supplies you used. You've worked hard. Have a wonderful, wonderful day. And remember, with practice, you'll be great.